The sonic signature that shattered the morning calm wasn't just noise. It was the sound of regional air power equations being rewritten forever. When the first Chengdu J-10C Vigorous Dragon touched Pakistani soil in February 2022, defense analysts across 3 continents held their breath. This wasn't merely another aircraft delivery. This was the operationalization of a strategic masterstroke that would fundamentally alter South Asian aerial supremacy dynamics and force adversaries to completely recalibrate their military doctrines. The Pakistan Air Force hadn't just acquired an aircraft. They had unleashed a technological apex predator into skies where the balance of power had remained static for decades. The J-10C's distinctive delta wing, canard configuration represents the pinnacle of aerodynamic engineering. Every curve, every angle has been meticulously calculated through extensive computational fluid dynamics modeling and exhaustive wind tunnel validation. This isn't aesthetic design, this is weaponized physics. The close-coupled canards don't just look impressive. They provide enhanced maneuverability at high angles of attack and low speeds, transforming dogfighting capabilities. These aerodynamic surfaces contribute to improved short-field performance, allowing operations from austere airfields that would challenge conventional fighters. The airframe's advanced composite material construction reduces structural weight while maintaining rigidity, directly translating to improved kinematic performance and increased payload capacity. Powering this aerodynamic masterpiece is the indigenous Shenyang WS-10B turbofan engine, a power plant that delivers approximately 32,000 pounds of thrust with afterburner. This thrust-to-weight ratio provides the J-10C with impressive acceleration and climb rates, critical attributes for both air superiority missions and precision strike operations. The WS-10B represents a quantum leap in Chinese engine technology, offering performance parameters that match or exceed contemporary Western engines in its class. Its integration ensures sustained supersonic flight capabilities and high-energy maneuvering potential that can outperform legacy platforms across the region. But raw power means nothing without precision control. Enter the quadruplex digital fly-by-wire system. The J-10C employs a sophisticated quadruplex digital fly-by-wire system that manages the inherently unstable canard delta configuration. This system provides artificial stability while allowing pilots to execute complex maneuvers that would be impossible with mechanical controls. Flight envelope protection prevents pilots from exceeding structural or aerodynamic limits, ensuring survivability in extreme combat scenarios. This advanced fly-by-wire architecture integrates seamlessly with the aircraft's complex sensor and weapon systems, ensuring precise control inputs translate directly into optimal aerodynamic responses. The system's built-in redundancy enhances survivability in contested environments where battle damage or electronic interference could compromise individual components. In modern aerial combat, whoever controls the electromagnetic spectrum controls the sky, and the J-10C dominates both. The aircraft's integrated electronic warfare suite represents a paradigm shift in spectrum dominance capabilities. The system includes sophisticated radar warning receivers, electronic support measures, and active electronic countermeasures that can jam, deceive, and spoof enemy radars and missile seekers. The passive detection components provide pilots with critical situational awareness regarding the electronic order of battle, enabling precise geolocation of threats for tactical maneuvering or targeted electronic attack. The active countermeasure system employs advanced techniques like digital radio frequency memory jamming, which can generate false targets or manipulate range and velocity data presented to enemy systems. This electronic warfare capability is particularly devastating in the South Asian context, where adversaries operate mixed fleets of advanced and legacy radar and air defense systems. The J-10C's ability to disrupt or neutralize these systems enhances survivability and mission effectiveness across the entire spectrum of conflict scenarios. The heart of the J-10C's combat effectiveness lies in its active electronically scanned array radar, a technological marvel that represents a generational leap over traditional mechanically scanned systems. Its agile beam steering allows near-instantaneous switching between multiple modes and targets simultaneously. The AESA radar provides superior detection range, resolution, and tracking capabilities, while maintaining low probability of intercept characteristics that make it nearly invisible to enemy radar warning receivers. This stealth-like quality allows J-10C pilots to observe and track adversaries while remaining undetected until the moment of engagement. Multi-mode functionality transforms the J-10C into a true multi-role platform. The radar supports air-to-air search and track, high-resolution ground mapping through synthetic aperture radar modes, maritime surveillance, and electronic attack functions. This versatility enables rapid mission reconfiguration based on dynamic battlefield requirements. Sensor fusion integrates data from the AESA radar, infrared search and track systems, electronic warfare suite, and data links into a comprehensive, deconflicted battlespace picture presented on intuitive multifunction displays. This creates unprecedented situational awareness that multiplies pilot effectiveness exponentially. The J-10C's 11 hardpoints accommodate a devastating array of modern munitions that rival or exceed Western equivalents in lethality and sophistication. This flexibility allows mission-specific configurations ranging from air superiority patrols to precision strike operations. The primary beyond visual range weapon, the PL-15 air-to-air missile, features a dual-pulse rocket motor extending kinematic range beyond 200 kilometers, providing J-10C pilots with decisive first-shot, first-kill advantages against contemporary platforms. Its active radar seeker incorporates advanced electronic countermeasures, making it highly resistant to defensive jamming attempts. For within visual range combat, the PL-10 high off-boresight missile offers capabilities comparable to the most advanced Western systems. Featuring an imaging infrared seeker and extreme maneuverability, it can be cued by helmet-mounted displays, allowing pilots to engage targets simply by looking at them. Ground attack capabilities include precision-guided munitions like laser-guided bombs, satellite-guided weapons comparable to JDAM systems, and anti-radiation missiles such as the CM-102. The CM-102's ability to home in on enemy radar emissions provides crucial suppression of enemy air defenses capabilities that can neutralize sophisticated ground-based threats. The J-10C's induction represents more than capability enhancement. It signals a fundamental shift in regional deterrence calculations. This acquisition moves Pakistan beyond reliance on legacy platforms, providing credible counters to advanced adversary systems like Indian Air Force Rafales and upgraded Su-30 MKIs. The J-10C's advanced radar, beyond visual range missile capabilities, and electronic warfare suite complicate adversary air operations while dramatically increasing the potential cost of aggression. The aircraft's multi-role capability provides unprecedented operational flexibility, allowing rapid transitions between air defense and strike roles based on evolving battlefield situations. This reduces requirements for specialized aircraft types while simplifying logistics and increasing sortie generation rates during high-intensity operations. Beyond immediate tactical implications, the acquisition signals deepening defense cooperation between Pakistan and China, providing access to cutting-edge military technology and potential future upgrades. This partnership diversifies procurement sources, reducing vulnerability to geopolitical pressures associated with single-source suppliers. For regional military planners, the J-10C's presence necessitates complete reevaluation of air combat tactics and strategies. Adversaries must now account for platforms with advanced AESA radar, long-range missiles, and sophisticated electronic warfare capabilities, requiring fundamental adjustments in mission planning, electronic warfare tactics, and force structure investments. Integrating sophisticated platforms like the J-10C requires comprehensive training programs utilizing high-fidelity simulators that replicate cockpit environments, flight characteristics, and sensor/weapon systems. These simulators enable pilots to practice complex maneuvers and combat scenarios safely while accelerating proficiency development. Pakistan Air Force pilots transitioning to the J-10C consistently praise its advanced human-machine interface. The glass cockpit featuring large multifunction displays and intuitive hands-on throttle and stick controls reduces cognitive workload compared to legacy aircraft, allowing greater focus on tactical decision-making rather than aircraft management. The advanced flight control system proves forgiving while enabling aggressive maneuvering. Pilots report that the fly-by-wire system manages aircraft stability seamlessly, enabling concentration on combat tactics rather than constant attitude corrections or trimming adjustments. The J-10C platform's modular architecture ensures relevance across decades of evolving threats and technological advancement. The aircraft's open architecture design facilitates hardware and software upgrades without requiring complete redesign. Potential future enhancements include advanced radar modes, integration of hypersonic weapon systems, improved electronic warfare capabilities, and deeper integration into network-centric warfare architectures. Experience gained through J-10C operations will inform future requirements and potential joint development projects, possibly leading to tailored variants optimized for South Asian operational environments. This collaboration could catalyze indigenous aerospace industry development, driving investment in technical training, infrastructure, and local manufacturing capabilities. The strategic impact extends beyond current capabilities through upgrade potential, ensuring long-term relevance. This adaptability represents crucial strategic value, providing sustained deterrent effects across multiple decades of service life. The J-10C represents a paradigm shift in South Asian air power dynamics, a technological catalyst that has fundamentally altered regional military equilibrium. Its sophisticated radar systems, advanced weaponry, and electronic warfare capabilities provide Pakistan with credible deterrent capabilities that compel adversary strategic recalculations. The Dragon hasn't just arrived in Pakistani skies. It has established dominance that will shape regional security architecture for generations to come. For military analysts and defense professionals worldwide, the J-10C's integration demands rigorous study of its performance parameters, operational deployment patterns, and future upgrade trajectories. This platform serves as a critical indicator of evolving capabilities and shifting power balances that will define 21st century aerial warfare. The sound that announced the J-10C's arrival was indeed more than noise. It was the sonic signature of a new era where technological excellence transcends traditional boundaries and reshapes the very foundations of regional air power. In the high-stakes theater of South Asian military competition, Pakistan has deployed a game-changing asset whose influence will reverberate across battlefields not yet imagined.